At this point, you've learned 3 methods to solve systems: graphing, elimination, and substitution. Okay, now all of these methods will work on any system. However, the length of time and effort and opportunity for mistakes varies a lot in how difficult they will be. So what we want to do is learn to choose the easy method that's going to save a lot of time and a lot of mistakes. Okay, so graphing, it's best to use this strategy when you're given a graph and 2 equations in slope-intercept form, and you can just graph them, right? This is especially beneficial if the slope is a fraction, right? Like if I can actually use substitution to solve in this situation, but especially if there's a fraction like this, it's a negative fraction, this is really easy for us to graph, but not as easy for us to solve an equation. So this is a great opportunity to use a graph, okay? Here's the big thing, right? Like you have to have a graph. So if on a test you're being asked to solve a system and you're not given a graph, you could sketch a graph always, right? But this is like a great one to use when you're given a graph, okay? Some disadvantages: it doesn't really allow for large numbers unless you have a big graph, or if the answer is a decimal, which sometimes it is, this will not be an accurate way to do it, okay? Now, elimination and substitutions, those are what's called the algebraic methods, right? I can solve by graphing, or I can solve algebraically, meaning using equations, okay? I'm going to use elimination if I'm given 2 equations in standard form. This is standard form, right? A number times x plus a number times y equals a number. This is my favorite place to use elimination. This is especially true if you already have, like, let's say this was a -4 and this was a +4. That would make it especially easy to use elimination here, right? But this one, I would use elimination on this system, okay? Some disadvantages: you might have to multiply one or both of these equations in order to get coefficients that are opposites. Like for example here, I could either multiply this bottom equation by 4, or I could multiply and then these would cancel, or I could multiply it by 3 and then this would be 9 and -9, right? I might have to do some steps here, but elimination is definitely my best bet if I have 2 equations in standard form. Whereas substitution, this is easiest if at least one of the equations is already solved for a variable, meaning, like, look, see, this y is by itself, so I can just take, right, this y is equal to this, so I can just take this 5x minus 7 and just plug it in right here for y. Okay. You can also use this if you have 2 equations in slope-intercept form and the numbers are too big to graph. Like, so if I had 2 equations that look like this, especially if I didn't have a fraction, and like let's say this number was like 20, I probably don't have a graph that goes up to 20. I could just set this 3x minus 4 equal to this and solve like that. Okay. You may have to solve for one of the variables first if you choose to solve a system that does not already have a variable isolated. So this was that extra credit assignment 11 if you did it. But substitution, you have to, kind of choose carefully. All right, so let's take a look at just 2 quick examples. Here's a system. I need to decide which method is best and why. And look, I've specifically given you, like, I've not given you a graph, okay? So you're just choosing the 2 algebraic methods for now. So let's take a look at this system. For me, the first thing that I notice is this y by itself. Whenever I have a variable that's already isolated, that's already by itself, I like to choose substitution. Okay, and why, right? The question is why? A variable is already isolated. And what does that mean? That means I can solve this easily because this y, which is the same as this y, is equal to this 4x plus 1. So I'm going to write this top equation, 3x plus 2y equals 13. Look, here's the same equation, 3x plus 2y equals 13, 3x plus 2y equals 13. But instead of y, what am I going to write? I'm going to write this expression that I know is equal to y. Okay, and then I'm like, right, this is that magical step where I just have an equation that just has one variable, and then I can use just my skills from, like, the first unit of algebra to solve this. I'm going to combine, all right, I distributed, and now I'm combining my like terms. I'm going to subtract 2 from both sides. I'm going to divide by 11 on both sides, and I get x equals 1. Okay, so I'm going to start with my answer is 1 comma something, and I'm going to take that x, and I'm going to plug it in here. Okay, so this is y equals 4x plus 1. Okay, look, this is me finding y. I'm going to take that x value, plug it in here. So 4 times 1 is 4, plus 1, my y is 5. Okay, so here's my answer. And I'm going to just go ahead and check it in this last column. And notice, look, I used this equation to find the y value. So I'm going to use the other equation to check the answer. This is 3x plus 2y equals 13. Okay, and I think that my x value should be 1 and my y value should be 5, and that should work out. Let's see. 3 times 1 is 3. 2 times 5 is 10. And this looks good. 3 plus 10 is 13. So I'm all set. Okay, there's my answer. Okay, down here, which method should I use? So here what I observe is that I have two equations in standard form. So I'm going to use elimination here. Okay, and why? Both equations are standard form. Okay, and in this case, I'm going to look right away and I'm going to see, oh, I don't have equations that already have opposite coefficients. Like I don't already have like a 3x and a negative 3x. So this one's going to be a little bit more work, but that's okay. This would be what we would call a level 3 elimination problem. And I'm going to right away, like there's nothing that I can multiply 4 by to get 7, or there's nothing I can multiply 3 by to get 5. So I can see right away I'm going to have to multiply both of these equations. I'm just going to go ahead and focus on the x's. Okay, so 3 times 5 is 15. I'm going to make one of these 15x and one of them negative 15x. This one's already positive. I'm going to just multiply it by 5, and that's going to equal 15x right here. And then here, I'm going to make this is going to be equal negative 15x. It's already negative. I'm just going to multiply it by 3. Okay, so we're going to multiply first. 5 times 3x, that's 15x. 5 times negative 4, and 5 times negative 5. Now I'm going to multiply across the bottom. 3 times negative 5 is negative 15x. 3 times 7 is 21. And 3 times 10 is 30. Okay, and now I have this wonderful situation where these are going to eliminate. So 15x minus 15x is 0. This is negative 20 plus 21. That's the same as 21 minus 20, which is just 1. This is just 1y, which is just y. This is the same as 30 minus 25, which is 5. Okay, so I have my y value. I'm going to use, let's just use this equation, this 3x minus 4y, to find my x value. So I'm going to take 3x minus 4y equals negative 5. I could have chosen the other equation too. It doesn't matter, right? I'm going to find the x value with one equation and then check it with the other. But right now I have a y value, so I'm going to plug that in. This negative 4 times 5 is negative 20. I'm going to add 20 to both sides. I'm going to divide by 3. And I get x equals 5. Okay, so I got 5, 5. Let's go ahead and check that. I'm going to grab the other equation. So negative 5x, oops, there you can't see that. Negative 5x plus 7y equals 10. Let's see, negative 5 times 5 is negative 25. 7 times 5 is positive 35. This is the same as 35 minus 25, and that does equal 10. So I'm all set.